All right, this is 11.1 part 2. I went over objectives 1 through 3, and we talked about how to find probability. Remember, if you see a capital P with an E, that means the probability that an event will occur. So whatever it equals is its outcome. So when we look at objective 4, we're going to talk about probability that an event will or will not occur. So P at E means the event will occur. What we've done in objective 1 through 3 is the probability that something will happen. Now we're going to talk about, well, how do we find the probability of something not happening or not occurring? So the probability of the event not happening means the event E will not occur. So probability of not E equals 1 minus the probability that the event occurs. Okay, so remember when we talked about probability, it has to be a value between 0 and 1. So probability of not an event happening means I take 1, which is the absolute, the ability of an event occurring, minus the probability that the event will occur. So probability not E is 1 minus, for instance, let's say the probability of the event occurred was 1/3. So I have to find a common denominator, so that 1 turns into 3 over 3 minus 1/3, which equals 2/3. Okay, so once again, if you're trying to find the probability of not an event occurring, you take 1 minus the probability that the event will occur. So how do you check this? If you take the probability of the event occurring plus what you found for the probability of not the event occurring, if you add those together, that should equal 1. Okay, because remember, 1 is the probability that something will happen every single time. Okay, so let's check out this next example. You have flipped a coin 10 times. Heads comes up 4 times out of the total tosses. So the probability that that event will occur is 4 out of 10 because your sample space is 10. And remember, I'm interested in heads coming up, so it's 4 over 10. So that reduces down to 2/5. The probability that the event will not occur is 1 minus the probability that it will occur. So we take 1 minus 2/5. I used the reduced value. I have to turn 1 into something of a common denominator, so 1 becomes 5 over 5, because remember 2/5 has the denominator of 5, minus 2/5. So 5 minus 2 in the numerator equals 3 over the denominator of 5. Okay, so once again, if I add 2/5 plus 3/5, I get 5/5, which equals 1. So let's try an example. A fair die is rolled. Remember, my sample space is 6, so I'm going to list it out. On a die or a dice, we have sides 1, 2, 3, 4, 5, and 6. For part A, it asks us to find the probability of rolling a 2. Well, there's only one side that has a 2, so remember, we're doing what we're interested in over our sample space, so it's 1 over 6. For part B, it says find the probability of rolling an even number. So I'm interested in an even number. So the even numbers on those sides of a dice are 2, 4, and 6. So I have 3 sides over my sample space of 6. 3 goes into 6 evenly, so that reduces down to 1/2. Part C, find the probability of rolling a number greater than 3. So I'm interested in a number greater than 3. So on a dice, that would be sides 4, 5, and 6, which is 3 sides, over the sample space of 6. That reduces down to 1/2. For part D, it says find the probability of not rolling a number greater than 3. This is an example of not the event occurring. So the probability of the event not occurring is 1 minus the probability of the event occurring. So remember that the probability of rolling a number greater than 3 was 1/2. So I'm going to take 1 minus 1/2, find a common denominator. So 1 becomes 2 over 2 minus 1/2, which equals 1/2. For part E, find the probability of rolling a number less than 7. Okay, so what I'm interested in is rolling a number less than 7. That means rolling a 1, a 2, a 3, a 4, a 5, or a 6. So I have 6 sides over the sample space, which is 6. So that's a 1. So that means you have a 100% chance of rolling a number less than 7. I wish that was a game at the casino. I would bet on that every single time. So if we look at this, if you haven't played with cards, and I know there's a couple people in here that probably haven't, what I did for you is I put in the notes what cards look like. By the way, the cards are a little weird that I did. So instead of a 1, all the cards have an A in them standing for ace. And they have suits. So we have hearts, which is the red cards with the hearts on them. The other suit is diamonds. So diamonds have a diamond on them, and it's also a red card. And then the black cards are clubs, and spades. So in each suit, there are 13, ranging from ace, going clear up to jack, queen, king. Jack, queen, and king are called face cards. J stands for jack, Q stands for queen, K stands for king. Okay, the reason why they're called face cards is because they literally have a face on them. So how do these cards read? Ace usually counts for 1 or 11 depending on what game you're playing. And then you have 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, and king. Okay, so there are 52 cards total. And like I said, I'm showing you a picture of them just so you can see. So for instance, if I wanted to know the probability of drawing a 7, there are 4 7s in the deck out of the 52 cards. So it's going to be 4 over 52, which reduces down to 1 over 13. Okay, so on this deck, an ace is denoted as a T. So make sure you put an A on there for ace. And then jack is a J, not a B, as this deck is showing. All right, so that's the end of 11.1. There'll be another video for 11.2.